This is part 2 of variation equations. We're going to be using the same equations we used in part 1, direct variation y equals k times x to the n, inverse variation y equals k divided by x to the n, and k in both of those equations is what we call the variation constant. So what I would like for you to do is to take this word problem, hit pause, and see if you can go ahead and answer part A. You can come back and check your work, and then do the same thing for parts B and C, hit pause and solve it so that you can tell whether or not you know how to break down the equation and know what numbers go where. All right, so hopefully you did that. As I read through this word problem here, I see that it is directly proportional to the square. So those two things are going to be important with the equation that I choose. Direct tells us to use this first equation up here and tells us that our exponent is going to be a 2. So I know that, and then I also need to figure out what my x and y variables are. So the one that comes first is my y, so the number of houses, that's my y, that can be served by a water main directly proportional to the square of the diameter. That's my x. A water main 10 centimeters in diameter, so again diameter, that's x, can supply 50 houses, that's y. So I kind of diagram or break down that word problem before I even start in on my working through the equations. All right, so I want to find the variation constant. Also, this asks us to find the variation equation. So again, there's two answers we need to find. Make sure you find both. Variation constant, I'm going to take this equation up here and put in 50 for y. I don't know the constant k. I'm going to put in 10 for x, and we said that the n value in this case was squared. So we have 50 equals 100k, divide both sides by 100, and k equals 1/2. So the variation constant is 1/2. Now we're going to use that to find the variation equation. We don't put any numbers in for y. We have our k value of 1/2. We don't put any value in for x, but we do know that our exponent is squared. All right, so please use that equation to answer questions B and C. Hit pause, come back, see if you got them right. How many houses could be served by a water main 30 centimeters in diameter? So the diameter is our x, so I'm going to put that in for x. Y equals 1/2 times 30 squared. And if I calculate that, I get 450 houses. And then a new subdivision of 1,500 houses is being planned. So that's my y. My constant still is 1/2. What size water main? I don't know x, but it does have to be squared. All right, so solving this one, we'd want to get rid of the 1/2 first. So want to multiply both sides by its reciprocal, multiplying both sides by 2. So we get 3,000 equals x squared. And then we would have to take the square root. So x equals 54.8. And then we need a water main. What are we measuring in? I have to go back to my original. Looks like centimeters. So 54.8 centimeters. Make sure you always label that final answer and don't just give me a number.